Hello, Internet. It is December 31st, New Year's Eve 2015, and I realized I only have 11 blog posts this year. And I kind of felt like I should have 12, like one for each month. And it was really bugging me, so I thought I would do one more just to send us off into 2016. A really quick and easy one about a concept that I really, really like. Anyone who watches my videos knows that I'm totally obsessed with MPLS, so any application for MPLS is always interesting to me. And this is the BGP Free Core. Admittedly, I feel kind of silly doing a video on it, mostly because it's a really well documented topic, and I don't know that I'll add a ton by doing a video on it, but I'll do this video anyway, show you what the BGP Free Core looks like, and I'll try and get some Wireshark captures up on my blog post about it so that you can see what packet flow looks like and kind of give a better idea as to what's going on. So the objective with a BGP free core, and the objective specifically of this video, is to have R1 be able to ping R2. See my mouse there? Big mouse. R1 down to R2. Ping via loopbacks only. We're not going to get into the actual physical interfaces. It would work the same, but I don't feel like doing it. So that's a great way to go into the video, right? I don't feel like doing it. So we're going to ping loopback to loopback between R1 and R2, only running BGP on PE1 and PE2. And the core here will not only not be running BGP, but also have no idea about how to reach the loopbacks of R1 and R2. And we're going to use the magic of MPLS to make this happen. So there are some base configurations here. I'm going to get Text Wrangler open now. I know with the super high res, ooh, stuff from before. Quick, look what I was entering in the past. I know with the super high resolution, you might not be able to see what I'm typing in the notepad here, but hopefully I'll pause long enough so that you can see it when it gets entered on these devices. So right now, if we go, and I'll give you a full walkthrough of everything, but we'll start off by looking at R1 and R2. If on R1 we do show IP route BGP, you can see that it has this one BGP prefix, which I assure you is the loopback of router 2. If we go over to router 2, we do show IP route BGP. It also has one BGP prefix learned. This is the loopback of router 1. If I try and ping router 1, sourcing from my loopback, you can see that nothing happens. Dramatic music, dun dun dun. So, what's going on here? We can go onto PE1. And on PE1, we can do show IP route BGP. You can look at this little diagram here. You can see R1's peering with PE1. So we have R1's loopback learned via eBGP. R2's loopback is learned via iBGP from this loopback address here, 10.22.22.22, which is the loopback address of PE2. So it looks like it should work right. We can do a show IP Ceph and see that we'll have two outgoing paths for this. We do. However, if we try and trace route to that, if we try and trace route to the right address, if we try and trace route to the loopback of router 2, we can see that both P1 and P3 have no idea how to get there. That can be confirmed by going to P1, we'll do show IP route, and all we have is OSPF learned routes. Furthermore, we can do show IP protocols, and see that we're only running OSPF. And this is true across all the P routers. P1, 2, 3, and 4 only run on OSPF, and we're going to do no redistribution, and this will work. So I say, to save some time, let's make the magic happen. And for those of you that just want to see it happen and make sure that BGP Free Core can work, you can watch, the next minute of this video. And then maybe we'll hang around a little bit longer and take a closer look at how everything's working. And again, I'll share Wireshark out on the blog post that I'll link to this video later. So what I'm going to do, I'm going to enable MPLS the easy way. We're going to go enable conft router OSPF. The process ID on all the routers that I set up is process ID 10. And I'm going to say MPLS LDP autoconfig. And that'll enable LDP on all of my interfaces that are participating in OSPF, which that's all we'd want to enable them on anyway. So we'll put that on P1. We'll put that on P1. There we go. And we'll put that on P2. P3. We have MPLS, or we have LDP neighbors coming up. P4, and then we have to run it on PE1 and PE2 also. All right, those of you that are impatient, I'll rerun the same ping, just arrow up. Oh my God, it works! All right, so that's all for the configuration. I wish that it was longer, and that's kind of why I feel silly doing a video. But really, that's the biggest part, is making sure that you have MPLS in the core. So why it works, and this is the part where if you're impatient, you shut off the video. Why it works is if we look at PE1, we do a show run section router BGP. It's a super short configuration, but there's a few things to point out. And before talking about it, I'll do the same on PE2. Okay. So on PE1, you'll notice that we're peering via loopbacks. I have my update source set to loopback 0, and I have next hop set to self. The next hop self, if you have any background configuring BGP, you understand why that's important because of NLRI. You might receive the prefix, but since IBGP doesn't change the next hop in the BGP table, it would show that the next hop to reach R1, for example, PE2 would show that as this link right here instead of the loopback that we're peering with, and wouldn't know how to reach it and blah, 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 boring stuff. So we do next hop self, but the other reason it's important is because we need to make sure that we have a label generated in our MPLS forwarding table to reach this prefix. So that's kind of a weird explanation. I don't like the wording on that, but I'm not going to re-record it, so deal with it. So if we look at our MPLS forwarding table, right? Well, let's jump ahead of myself. So let's do a show IP routes BGP. So this is the prefix for router 1's loopback. So we know that we're going to have to go to PE1. We're seeing that reachable via 10, 11, 11, 11. That's our next hop self, and the fact that we're peering via loopbacks gives us that. And then we can do show MPLS forwarding table. And down here at the bottom, you can see that we have local label 28, outgoing label 25 for both of our outgoing interfaces to reach 10, 11, 11, 11. So what that means is when PE2 receives traffic from R2, right, and is going to forward it on to PE1, it's going to encapsulate that MPLS, and then the core doesn't have to be remotely aware of anything else. All it's going to look at is the labels for that MPLS traffic. And that's why P1 and P2 and P3 and P4, none of them have a route to reach anything in the 172.16 network. So we'll look, I can type 16. 1.1, it's not in the table. 2.2, not in the table. And you have a BGP Free Core. So I know this was like probably the shortest video that I've ever made, but I wanted to give one more for the year. I'll have Wireshark capture and additional details on my blog post. And before I sign off, just in fairness for those that want to try and recreate this, I'll do a show run section router on all devices. So you can see there's no tomfoolery happening. Show run section router, only running OSPF, MPLS LDP auto, and then all the interfaces inside of the core here are on the 10 dot space. So every interface starting with 10 dot is dumped into area 0. And it's the same on all of our P devices. This one, and then you'll see on PE2 we're running BGP and OSPF, and the OSPF config is identical as it was on the P devices. Here's our eBGP peering with router 1, and then our super basic, nothing special setup peering with PE2. Get that back in clipboard. And finally, router 1 and router 2 have next to no configuration at all, just a basic BGP setup where they're advertising their loopbacks. So you can see right there. So, again, super brief video, just talking about our BGP Free Core utilizing MPLS. Look to the blog post for any Wireshark captures and additional information. And I'll see you guys in